Hi and welcome to the 10th video on kinematics. Today's video will involve free-falling objects and we'll get to use the equations of kinematics to find certain variables. The question today reads, a hot air balloon having a constant velocity of 72 kilometers per hour is rising vertically from the ground. When it reaches the height of 150 meters, a stone from the balloon is dropped. Question A. How long does it take to strike the ground? Question B. What will be its velocity when it strikes the ground? These are the two things we'll be looking for. Before we begin solving, let's visualize this situation. So we have a hot air balloon. We are told that it is rising vertically with a velocity 72 kilometers per hour. But let's convert this to meters per second. 72 kilometers per hour in meters per second is 20 meters per second. Now, what else are we told? When it reaches the height of 150 meters, let this be the ground, then it goes up to a height 150 meters. At this point, 150 meters, we are told that a stone is dropped from it. Okay, so when the stone gets dropped from the air balloon, the stone will initially also be going at 20 meters per second upwards. So once it's let go, it will go a short distance up, then it will start coming back down and get to the ground here. So when it's let go at this position at 150 meters, it's going to go up some distance, a very short distance, before it starts coming back down. And its initial velocity will also be 20 meters per second. So let's gather our data. V initial of the stone is 20 meters per second. The final velocity, we don't know the final velocity, and question B is actually asking us to find the final velocity. What else? We have acceleration. Acceleration, because it's free fall, is negative 9.8 meters per square second. It's negative because initially the stone is going upwards, so it's going against the pull of gravity. What else do we have? We have displacement, 150 meters. Now, because the object is going up and then it goes down, there are two displacements or two directions of displacement. If we take this as the reference point or the 0 point, the velocity going upwards we can take as positive and the velocity down will be negative. Now we do this because picture we wanted to find some velocity or some displacement that's here, between this point and this point. If it's maybe 10 meters, well, there is also another displacement of this same object 10 meters below. So to differentiate the two, one will be positive and the other will be negative. The one going up we take as positive, the one coming down we take as negative. Okay, based on this information, and we're also looking for time. We don't know time. It's the one we're looking for in question A. So based on all this information that we have, which kinematics equation would be best to find the time? So based on all these equations, or based on all this information we have, this equation would be the best. Because we have displacement, we have initial velocity, and we have acceleration. The only variable that's missing is time. So let's go ahead and plug the information we have. Displacement is negative 150. Initial velocity is 20 times t plus half, negative 9.8 t squared. This simplifies to negative 150, 20t. This cancels and we have 4.9 here. So this is minus 4.9 t squared. Now, let's rearrange this equation, taking these two to the left-hand side. We'll have 4.9 t squared plus, or this becomes minus since it's positive 20. So it becomes minus 20t minus 150 is equal to 0. Now at this point, we have this equation that's in the form of a quadratic equation. Therefore, we have to solve it as such. We use the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac divided by 2a. So this would be our a, this is our b, and this is our c. Let's plug them into the equation. So negative, our b is negative 20. This is plus or minus the square root of negative 20 squared minus 4. Our a is 4.9 and our c is negative 150 divided by 2 times 4.9. Negative and negative give us a positive, so that's positive 20 plus or minus square root. What's 4 times 4.9 times 150? And this is negative times negative, so we'll have positive. And now multiply 4 times 4.9 times 150. 2940 divided by 2 times 4.9, that gives us 9.8, making this becomes 77.8 over 9.8, or negative 37.8 over 9.8, making this side 7 point. Which answer should we take between t equals 7.9 or t equals negative 3.9? Because time can never be negative, this one is wrong. So we'll take t equals 7.94 seconds. Therefore, our final answer is t equals 7.94 seconds. The next question is asking us what will be its velocity when it strikes the ground. Okay. So the velocity when it strikes the ground, we have, now that we have time, t equals 7.94. What equation can we now use to get velocity? We can use the equation v equals v naught plus at. Our initial velocity is 20 plus acceleration is negative 9.8. Our time is 7.94. This gives us 20 minus 77. So therefore our velocity is equal to negative 57.8. Now the negative is because of the fact that when it is coming back down and when it's hitting the ground, its velocity is in this direction. Remember, the upward direction had positive 20, so the downward direction now gives us negative 57.8 meters per second. Now, there's another way we can get the velocity which won't give us a negative. So because of all the information we have, we can also use the equation v squared is equal to v naught squared plus 2as. Our initial velocity is 20 squared plus 2 negative 9.8 and negative 150 is our displacement when it hits the ground. So this will give us 400 plus 2940. This becomes 3340. Now this is v squared is equal to this, so we take the square root on both sides. This becomes velocity is equal to 57.8 meters per second. Now our answers are the same numerically, but one has a positive and one has a negative. Well, for the second one, we just have to say velocity is equal to 57.8 meters per second downwards. So because we know it's coming down in this direction, then we'll put downwards. But for the other one, it gives us the answer negative 57.8 meters per second.